Hey guys. So for the last bit of this lecture, I want to tell you a little bit about the models that we're using to predict future climate change. So I'm going to talk about the models that the IPCC is using. So the IPCC is the Intergovernmental Panel on Climate Change, and they're the body that produces regular assessment reports that summarizes and brings together everything we know about climate change. And the IPCC uses what we call integrated assessment models. They're models that incorporate lots of different components, looking at the economy, but also biophysical conditions, to simulate the effects of economic growth on the carbon cycle, climate, weather, and therefore ecosystems and human systems. And these integrated assessment models are used to assess how different socio-economic circumstances change economic growth and therefore change the climate. Now, let me show you a bit of a schematic of what an integrated assessment model looks like. Like I said, the main idea is modeling economic growth. So, typically, economic growth is associated with an increase in energy use and therefore an increase in greenhouse gas emissions. Now, climate models are then used to model these economic growth models are linked to geophysical models that simulate how greenhouse gas emissions influence the global carbon cycle. And they're then linked to climate models, which simulate how changes in carbon affects temperature, rainfall, cloud forming, sea levels, oceans around the world. Now they then aim to estimate how these changes in climate affect ecosystems, agriculture, invasive species, spread of diseases, in all things that affect human well-being. Now, of course, what you can do is simulate changes in policies that may affect economic growth or may affect the level of greenhouse gas emissions that comes with economic growth, such as limiting pollution, raising taxes on emissions, or subsidizing alternative uses of energy. Alternative sources of energy, I should say. Now, if you go to the latest IPCC assessment report, which at the time of recording this lecture is the 5th assessment report, you can see the different types of drivers that are included in these integrated assessment models. They could be, for example, population growth, and then what they do is they estimate a default, a low growth and a high growth scenario. They estimate different ways that GDP could develop over the world. We could get a lot richer, or on average, or maybe not such a high growth. They look at energy intensity changes. Energy intensity is how much energy we use per person, and also the carbon composition of energy. So whether we use more or less renewable energy, for example. So the IPCC then takes the predictions of a lot of different models to come up with average predictions and highest and lowest predictions, different scenarios. And these models range from simple energy balance models to very complex dynamic models that simulate the whole Earth system and integrate socioeconomics and geophysical models. If you go to the IPCC report, all those models that they use are summarized, and you don't have to know them, of course, but I just want to show you, lots and lots of different models which cover lots of different components that are relevant to climate change. Now, what the IPCC models do is they don't necessarily look at socioeconomic scenarios per se, but they look at what they call representative concentration pathways. So the idea is that different types of socioeconomic scenarios could result in different levels of radiative forcing. If you think back to the very first slide that I showed in my first lecture, it showed radiation from the sun going in and being reflected. So what we're aiming for here is different levels of that reflection, the different levels of radiative forcing in the atmosphere. And these 4 scenarios that they look at is these 2.6, 4.5, 6 and 8.5 could be a result of different possible economic futures. So it's just information showing you these 4 RCPs, RCP 6, RCP 4.5, RCP 2.6, and then also RCP 8.5, which results in a radiative forcing that's a lot higher than 8.5. I don't know why they've chosen that, but essentially what you see is that at the moment we can still increase, but then it needs to level out pretty quickly if we are to follow that, if we are to achieve that RCP 2.6, that representative concentration pathways. So just to repeat that RPCs are internally consistent sets of forcing projections that could be realized with different underlying socioeconomic scenarios. And what these integrated assessment models do is they look at the result of these radiative pathways. So let's look at these predictions. Here again, I've shown you those 4 RCPs, 2.6 and 8. Let's look at 2.6 and 8.5. And these are predictions resulting from that whole set of models. And what I'm showing you in this graph is the average prediction, which is under an 8.5 scenario, that in the next century, global surface temperature could increase by more than 4 degrees. This is massive. If we're going for a low emission scenario, RCP 2.6, temperature will still increase, but we might be able to limit it to a 1 degree increase on average. These bars here on the side show you the, it's like an error bar, show you the variation in predictions from all those different models. We don't know which pathway we're on, but let's hope that our actions won't take us to this scary 8.5 scenario. Now, what do I want you to remember from this lecture? Mostly want to convey to you how important it is that you look at the data, analyze the data, and analyzing data is a vital component of climate science. We want to know whether the temperature and also weather events are changing, and whether they're changing more than normal. Is that slope significantly different from zero? I've also told you a little bit about integrated assessment models. That's mostly a bit of background information on how we use models to predict future climate change. In the next lecture, I'm going to talk about the cost and benefits of climate change, a little bit more economics. So I'm going to leave it there. I just watched this show last night, Cosmos, which is a really good show by Neil deGrasse Tyson, and this episode that I've linked to here is on climate change. So if you're a fan of Neil deGrasse Tyson, I highly recommend this show, and I'll see you next week.